Hi and very good morning to Dr. Faiza, and I'm from Group 5, and we will be presenting to you about game theory today. And let me introduce myself first. I'm Arshvini and my metric number is 184183. And today I'll be presenting to you about the two-person zero-sum game. So as you see, there are a few characteristics for the two-person zero-sum game, which are there must be two players, and there must be fixed set of strategies. Zero sum implies that the loss of one player is the exact gain of the other, and pure strategy refers to a prescribed solution in which one alternative is repeatedly recommended to each player, and bargaining is not allowed. There could be no agreement that could be mutually advantageous in this game. So as an example, first one would be penny matching. Each of the two players has a penny. Two players must simultaneously choose whether to show head or the tail. Okay, there are a few rules. If two pennies match, it's either heads or both tails, then player 2 will win the player 1's penny. If it's otherwise, if it's in vice versa, the player 1 will win the player 2's penny. Okay, as a second example, which is the prisoner's dilemma. Okay, in this game, the two players are partners in crime who have been captured by the police. Each suspect is placed in a separate cell and offered the opportunity to confess to the crime. The game can be represented by the following matrix of payoff. Okay, as you see here, if the prisoner 1 doesn't confess and the prisoner 2 also doesn't confess, each of them will get 5 years of jail, each of them. So if one person doesn't confess and one person confess, the person who confessed will set free for 10 years. He will be set free, and the person who didn't confess will get 6 years of jail. If this person confess and the other one doesn't confess, the person who confessed will be set free, and the one doesn't confess will have 6 years of jail. If let's say both of them confessed, so each of them will get 1 year of jail. So as you see, if both prisoners confess, then both are given a reduced term, but both are convicted, which we represent by giving each 1 unit of utility, which is much better than having the other prisoner confesses but not as good as going free. So that's all from me, and thank you, doctor.
Assalamualaikum and good morning to Dr. Faiza. My name is Nurul binti Ishaq. My metric number is 184097 from Group 5. The example of constant sum game of two-person player is can be seen from saddle points. Example of the question is during the 8 to 9 p.m. time slot, two networks are vying for an audience for 110 million viewers. The networks must be simultaneously announce the type of show they will air in that time slot. The possible choices are shown in the following table. So there is two networks, which is network 1 and network 2. So for example, if both of the network choose a western, the matrix indicates the 45 million people will watch network 1 and the remaining of 110 million, which is 65 million people, will watch network 2. Thus we have a 2% constant sum game with the total of the viewers is 110 million. So does this game have saddle point, and what is the value of the game of network 1? So by looking at the row minima, we find that by choosing a soap opera, network 1 can be sure of at least maximum 55 million viewers. looking at the column maxima, we find that by choosing a Western, network 2 can hold network 1 to at most minimum 55 million viewers. So, since the value of maximum and minimum is 55 million, we can find that the equation 1 is satisfied. Thus, network 1 choosing a soap opera and network 2 choosing Western yield a saddle point. Neither side will do better if it is an alternative change strategy. As conclusion, the value of game network 1 is 55 million viewers and the value of game 2 network 2 is 55 million viewers. The optimal strategy for network 1 is to choose a soap opera and the optimal strategy for network 2 is to choose Western.
Bismillahirrahmanirrahim. Assalamualaikum and a very good evening. So my name is Amirul, Ashraf, Aiman bin Muhammad Nizam and my metric number is 183185. I'm from group 5, so I'm going to continue the presentation for game theory under dominant strategy, which are reducing by dominance. So let's have a look at the slides. So these are the slides, reducing by dominance. One move dominates another if all its payoff are at least as advantageous to the other player than the corresponding ones in the other move. In terms of the payoff matrix, we can say it this way. Row R in the payoff matrix dominates row S if each payoff in row R is more than or equal the corresponding payoff in row 2. Second, column R in the payoff matrix dominates column S if each payoff in column R is less than or equal corresponding payoff in column S. So note that if two rows or columns are equal, then each dominates the other. A row or column strictly dominates another if one dominates the other and they are not equal. Following the first principle of game theory, the move corresponding to a strictly dominant row or column will never be played, and both players are aware of this by the second principle. Thus, each player following the principle of the game theory will repeatedly eliminate the dominated rows and columns as the case may be. If two rows or columns are equal, then there is no reason to choose one over the other, so either may be eliminated. This process is called reduction by dominance. So for example 1, in the first step, third row is removed, which was dominated by the fourth row. We can see the third row are much more smaller compared to the fourth row, so the bigger row will eliminate the smaller row. In the second step, second row is removed, which was dominated by the first row. We can see the second row also much more smaller if compared to the fourth row, but that's why the second row is eliminated. In the last step, third column is removed, which was dominated by the second column. Third column was removed, which was dominated by second column, because we can see second column is much more smaller if compared to the third column. So the third column is eliminated from this matrix. So the final answer is 2 times 2 matrix, because we find that none of the column and row can be reduced any further. For example 2, which is much more similar to example 1. In the first step, we remove first row, which was dominated by the second row. We can see that first row are much more smaller if we compare to the second row. That's why we remove the first row. So in the second step, we remove second column, which was dominated by the third column. Second column was removed because the third column is much more smaller compared to the second column. In the third step, we remove third row, which was dominated by the second row and also fourth row. We can see in the second step, the third row was removed because of the second row, and the fourth row dominated the third row, since the third row are much more smaller compared to the other row. For the final step, we remove fourth row, which was dominated by the second row, and we can see here the second row is much more bigger if compared to the fourth row. So the final answer for this result metric is 1 times 2 metric. Thus the game cannot be reduced any further because none of the row and column are dominated. So that's all from me. Thank you, Dr. Faiza. Assalamualaikum.